Good morning. I am Dr. A. Kalai Selvi. Today I present the topic rule-based expert system. Expert system interfaces employ a variety of user styles that includes question and answer, menu-driven or graphical interfaces. The final decision on the interface type is a compromise between user needs and the requirements of the knowledge base and inferencing system. The heart of the expert system is the knowledge base, which contains the knowledge of a particular application domain. In a rule-based expert system, this knowledge is most often represented in the form of if-then rules. Rule-based expert system represent problem-solving knowledge as in the form of if-then rules. It is also one of the most natural and remains widely used in practical and experimental expert system. If-then else is a practical experimental expert system. If we regard the expert system architecture as a production system, the domain-specific knowledge base is the set of production rules. In a rule-based system, these condition-action pairs are represented as if-then rules with a premises of the rules. The if portion corresponding to the condition and the conclusion, the then portion corresponding to the action. When the condition is satisfied, the expert system takes the action of asserting the conclusion as true. That is, in a if-then else, if the condition is true, it executes the then part. Otherwise, execute the next statement. That is the structure. Case-specific data can be kept in the working memory. The inference engine implements the recognize act cycle of a production system. This control may be either data-driven or a goal-driven. As an example of goal-driven problem solving with user queries, we next offer a small expert system for analysis of automotive problems. This is not a full diagnostic system as it contains only some few rules. It is intended as an example to demonstrate goal-driven rule chaining, the integration of new data and the use of explanation facilities. That is, the rule is the first rule, one of the that is the examples. If the engine is getting gas and the engine will turn over, then if it is true, if the condition is true, the problem is spark plugs. The problem is spark plug flux. Okay, the next rule 2. If the engine does not turn over and the lights do not come on, then the problem is battery or cables. That is battery low or some cables are not connected. That is the problem. Then rule 3. If the engine does not turn over and the lights do come on, then the problem is starter motor. Correct currents are not coming. Then the problem is starter motor. Then rule 4. If there is gas in the fuel tank and there is gas in the carburetor, then the engine is getting gas. Okay, this is the rule, sample rules. Okay, then to run this knowledge base under a goal-directed control regime, place the top level goal, the problem is X. In working memory, X is a variable that can be matched with any phrase. As an example, the problem is battery or cable. It will become found to the solution when the problem is solved. Okay, thank you.